In this lesson, we will identify polynomials which are perfect cubes and then use these cubic formulas to manipulate some interesting properties of algebraic expressions. If you remember, the integers 1, 8, 27, 64 were called perfect cube just because 1 could be written as 1 power 3, 8 could be written as 2 power 3, 27 could be written as 3 power 3, 64 could be written as 4 power 3. And this continues on. When we started using symbols or variables, then we can similarly translate that concept into the variables, and we say that the variable y is called a perfect cube if it could be written as cube of another variable x. So therefore y is called a perfect cube because it can be written as power 3 of another variable x. Now similarly, if you consider this expression a cube plus 3a square b plus 3a b square plus b cube, this can be written as perfect cube of a plus b and hence must be called a perfect cube. So this polynomial is a perfect cube as it could be written as power 3 of a plus b, and also a cube minus 3a square b plus 3a b square minus b cube is equal to a minus b whole cube. So this polynomial is also a perfect cube. So these two cubic formulas will lead us to some interesting properties of the polynomials. For example, if we discuss properties here, we can not only verify that a plus, so property 1, we could be asked that verify that a plus b whole cube is equal to a cube plus 3a square b plus 3a b square plus b cube. And this verification is really simple verification. In this and many other verifications, we are going to consider the side which we can work on, and that is left hand side. If you take left hand side here, left hand side is equal to a plus b cube, and a plus b cube is, in fact, we can write it as a plus b times a plus b whole square. Now if you remember the a plus b, the perfect square polynomials, a plus b whole square is equal to a square plus 2ab plus b square. So we can use those formulas, this perfect square formula, and a plus b times a square plus 2ab plus b square. And now by performing actual multiplication, we will multiply this entire polynomial one time with a and another time with b. So this would become a times a square plus 2ab plus b square, and then plus b times a square plus 2ab plus b square. And if you multiply, this would become a cube plus 2a square b plus a b square plus a square b plus 2a b square plus b cube. And now adding the like terms, there is 2a square b and there is a like term a square b. So this will give us a cube plus 3a square b. And now ab square and 2ab square, these are like terms, and on adding they will give us 3a b square plus b cube. See, we have satisfied, and this is equal to right hand side. That's exactly what was required. Therefore, we can say that a plus b whole cube is in fact equal to a cube plus 3a square b plus 3a b square plus b cube. And if you were required to verify the second property as well, if the second property would be, if you were to prove that a minus b whole cube is equal to a cube minus 3a square b plus 3a b square minus b cube. We have just verified this result number 1, and we can either do the same thing with this one with the second property, or in fact we can also do the replace b by minus b in equation 1. We can replace b by minus b in equation 1. If we replace that, then this would become a plus minus b whole cube equal to a cube plus 3a square times minus b plus 3a minus b square plus minus b cube. And you can see that if negative is within odd power, it gives out minus, otherwise it becomes simply plus. So this will become a minus b whole cube, and this would become equal to a cube minus 3a square b plus, because the power of minus b is even, this will become 3ab square minus b cube, because the power here is odd, so it will give out the minus b. So this, you can see that this second result is also verified, but you don't have to do this way. If you want to repeat the similar procedure which we did in property number 1, we can similarly do that. And there is another property number 3, and that is a cube. Prove that a cube plus b cube is equal to a plus b times a square minus ab plus b square. This formula is also to be memorized and is used very frequently. Instead of relying on the formula sheet, I would advise my students to memorize these algebraic formulas. And here we have a cube minus b cube, that is first property, and then that is second, is equal to a minus b into a square plus ab plus b square. So if we want to prove this property number 1 here, and we can, again, we have direct proof. Either we can multiply the right hand side, which is the easiest way. We can multiply the right hand side, and then we will see this becomes equal to left hand side. So let's do that by direct multiplication. So right hand side is equal to a plus b times a square minus AB plus B square. And now we are going to multiply this entire polynomial with the first as well as the second one. So A times A square minus AB plus B square plus B times A square minus AB plus B square. So by direct multiplication, we multiply this. This will become A cube minus A square B plus A B square plus A square B minus A B square minus plus B cube. Therefore, we can see that minus A square B plus A square B are like terms, but because they are the same terms with opposite signs, so they will cancel out. And plus AB square and minus AB square, they are like terms, so they will cancel out, and the result would be equal to A cube plus B cube, which is equal to left hand side. So this is another proof. And the second property, this one, you can either use the same direct multiplication procedure, or you can replace it in the first one, you can replace B by minus B. So second, I'm not going to do that. Second left for you to prove. And these are the main formulas, but there are two other formulas which are very important, and those formulas are A plus B property number. That was property number 3, and now this is property number 4. That property is A plus B plus C whole square is equal to A square plus B square plus C square plus 2AB plus 2BC plus 2CA. So this formula, which can be proved again, the proof is really simple because the left hand side is expandable, and left hand side could be expanded as A plus B plus C whole square if we want to do the direct multiplication. We can do the direct multiplication, otherwise A plus B can be named as D, and then, but let's do the direct multiplication. So if we do the direct multiplication, this could be written as A plus B plus C times A plus B plus C, and now this whole expression could be multiplied one time with A, one time with B, one time with C. So this would be equal to A times A plus B plus C plus B times A plus B plus C, and then plus C times A plus B plus C. Now here it will give A square plus AB plus AC plus AB plus B square plus BC plus AC plus BC plus C square. And now if we collect the terms to A square plus B square plus C square, so this term, and this term, we are done. And AB, and there is another AB which is right here. So this AB and AB will become 2AB, and then BC and BC will become 2BC plus AC and AC will become 2AC. This gives us the right hand side. So this is like that. And now the last one, and that is equally important. So this was property number 4, property number 5. Number 5, and that is A cube plus B cube, A cube plus B cube plus c cube minus 3abc is in fact equal to a plus b plus c time a square plus b square plus c square minus ab minus bc minus ac. So this is again a very important property which can be proved by direct multiplication on the right hand side. So right hand side, if you want to prove it, a plus b plus c and then multiply it with a square plus b square plus c square minus ab minus bc minus ac, and then once this multiplication is done, this will become equal to left hand side. I will leave this simplification for you, but these 5 properties must be memorized, otherwise you are going to need the formula sheet over and over again. Let's use one of these properties in one question. Here the question is that find the value of x cube plus y cube plus z cube minus 3xyz when what is given? What is given is x square plus y square, x square plus y square plus z square, which is given equal to 77, and what else is given, and x plus y plus z is equal to 15. Now solution. If we remember the formula we have for this expression, x cube plus y cube plus z cube, the form minus 3xyz, the formula we have is that this should be equal to x plus y plus z time x square plus y square plus z square minus x y plus minus yz minus xz. Now we have everything here on, we have the value for x plus y plus z which we can replace. We have the value for x square plus y square plus z square which is 77 and we can replace. But the problem still is that we don't have the value for xy plus yz plus xz. So therefore we are going to name this as number 1, and now we are going to try to find the value for x plus xy plus yz plus xz, and then we will further, or we can make it one more step and we can write x square plus y square plus z square minus 3xyz equal to x plus y plus z into x square plus y square plus z square, and take the minus common and leave it xy plus yz plus xz, so that when we have the value for xy plus yz plus xz, we can just plug in that value here. So we'll take advantage of x plus, since x plus y plus z is given that this is equal to 15. Let's take square on both sides. Take square on both sides. That will give us x plus y plus z whole square is equal to 15 whole square. So this would be x square plus y square plus z square. That is property number 4, I guess. That the property number 4 states that this is equal to x a square plus b square plus c square plus 2ab plus 2bc. So this would become plus 2xy plus 2yz plus 2xz equal to 15 square mean 225. So what is the value for x square plus y square plus z square? The given value for this is, here the given value is 77 here. In this question this is given 77, so we're gonna plug in that value 77 and then take 2 common, xy plus yz plus xz equal to 225. So now take 77 on the other side, so this will give us 2xy plus yz plus xz equal to 225 minus 77, and that will give us 2 times xy plus yz plus xz equal to 148. And once we have this, we can divide both sides by 2, this side and this side, which gives us xy plus yz plus xz is equal to 74, and this value can be plugged back in equation number 1. You remember that we identified that this part we don't have the value for, therefore we're gonna plug in that 77 over here. We'll say that here we can either just do here x plus y plus z is given, x plus y plus z is given that this is 15, so let's put this equal to 15 times this is 77 minus 74 for this one, and that gives us equal to 77 minus 74, that would give us 3 times, so this would become 45.